Are you tired of doing the same reports over and over again? Are you tired of losing files and gathering the same data every time you have to submit a different report? Would you like to save time and stress in your work? Is that a yes? Then what you need is data management. Data, data, data. We hear so much about it, but do we really understand the importance of data collection? At its most basic, data is simply a collection of different facts. It includes numbers, measurements, and observations that have been translated into forms that are understood and processed by a computer. This might sound easy, but data is effectively changing the world that we live in and the way that we work. No matter the industry that you work in, data collection is at the heart of every decision that we make. So why is data collection important? Data empowers you to make informed decisions. Data equals knowledge. The more data you have at your own disposal, the better position you'll be to make good decisions and take advantage of new opportunities. Data saves time. Having a smart data collection in place will save you a valuable time down the road. So many resources are being wasted for gathering the same data over and over again. A data collection system will gather and display data in a way that is easy to access and navigate, meaning everyone who is part of your organization will save time. Data lets you know your strengths and challenges. It helps you solve your problems and understand your performance. Data is also essential in understanding your clients and getting the results that you want. But with so much information out there, how can we be able to get the right information so that we could get the best decisions for our organization? Hi, my name is Ruby, and in this video, we're going to talk about data resource management. Data are a vital organizational resource that needs to be managed like other important organizational assets. Today's enterprises cannot survive or succeed without quality data about their internal operations and external environment. That's why organizations need to practice data resource management, an administrative process that includes acquiring, validating, storing, protecting, and processing required data to ensure the accessibility, reliability, and timeliness of the data for its users. This video will show you the following topics. Number 1, file organization terms and concepts. Number 2, problems with traditional file environment. Number 3, database management approach. Number 4, types of databases. Number 5, implementing data resource management. And lastly, database structures. Before we go any further, let's review some fundamental concepts about how data are organized in an information system. A hierarchy of several levels of data has been devised that differentiates between different groupings or elements of data. Thus, data may be logically organized into characters, fields, records, files, and databases, just as writing can be organized in letters, words, sentences, paragraphs, and documents. Let's start with character. The most basic logical data element is the character, which consists of a single alphabetic, numeric, or other symbol. Considering the physical storage elements provided by a computer hardware, bit shall be considered as the smallest unit of data. Byte is a group of bits that represents a single character. From a user's point of view, that is from a logical as opposed to a physical or hardware view of data, a character is the most basic element of data that can be observed and manipulated. The next higher level of data is the field or data item. A field consists of a grouping of characters. For example, the grouping of alphabetic characters in a person's name forms a name field, and a grouping of numbers in sales amount forms a sales amount field. An entity is a person, place, thing, or event on which we store and maintain information. Each characteristic or quality describing a particular entity is called an attribute. Specifically, a data field represents an attribute, a characteristic or quality of some entity, object, person, place, or event. For example, an employee's salary is an attribute that is typical data field used to describe an entity who is an employee of a business. Related fields of data are grouped to form a record. Thus, a record represents a collection of attributes that describe an entity. An example is payroll record for a person, which consists of data fields describing attributes such as the person's name, social security number, and rate of pay. A group of related records is a data file or table. Thus, an employee file would contain the records of the employees of a firm. Database. A database is an integrated collection of logically related records or objects. An object consists of data values describing the attributes of an entity, plus the operations that can be performed upon the data. A database consolidates records previously stored in separate files into a common pool of data records that provides data for many applications. The data stored in a database are independent of application programs using them and of type of secondary storage devices in which they are stored. For example, a personal database consolidates data formerly segregated in separate files such as payroll files, personal action files, and employee skills files. The image that you can see here is a computer system that organizes data in a hierarchy that starts with a bit, which represents either a 0 or a 1. Bits can be grouped to form a byte to represent one character, number, or symbol. Bytes can be grouped to form a field, and related fields can be grouped to form a record. Related records can be collected to form a file, and all related files can be organized into a database. Problems with the traditional file environment. In most organizations, systems tend to grow independently and not according to some grand plan. Each functional area tended to develop systems in isolation from other functional areas. Accounting, finance, manufacturing, human resources, and sales and marketing all develop their own systems and data files. This illustrates the traditional approach to information processing. The use of a traditional approach to file processing encourages each functional area in a corporation to develop specialized applications. Each application requires a unique data file that is likely to be a subset of a master file. These subsets of the master file lead to data redundancy and inconsistency, processing inflexibility, and wasted storage resources. Each application, of course, required its own files and its own computer program to operate. For example, the human resources functional area might have a personal master file, a payroll file, a medical insurance file, a pension file, a mailing list file, and so forth, until tens or perhaps hundreds of files and programs existed. In the company as a whole, this process led to multiple master files created, maintained, and operated by separate divisions or departments. As this process goes on for 5 or 10 years, the organization is saddled with hundreds of programs and applications that are very difficult to maintain and manage. The resulting problems are data redundancy and inconsistency, program data dependence, inflexibility, poor data security, and an inability to share data among applications. The database management approach. Database technology can cut through many of the problems a traditional file organization creates. The development of databases and database management software is the foundation of modern methods of managing organizational data. The database management approach consolidates data records and objects into databases that can be accessed by many different application programs. In addition, an important software package called a Database Management System, or DBMS, serves as a software interface between users and databases. This helps users easily access the records in a database. Thus, database management involves the use of database management software to control how databases are created, interrogated, and maintained to provide information needed by end users and their organizations. For example, Customer records and other common types of data are needed for several different applications in banking, such as check processing, automated teller systems, bank credit cards, saving accounts, and installments loan accounting. These data can be consolidated into a common customer database rather than being kept in a separate file for each of these applications. Basically, a database management system has three components: a data definition language, a data manipulation language, and a data dictionary. So let's go over to these terms. Data definition language. So when we say data definition language, this is the formal language programmers use to specify the structure of the content of database. The data definition language defines each data element as it appears in the database before the data element is translated into the forms required by application programs. Data definition language can be used to add, remove, or modify database and tables. Next, how about data manipulation language? It consists of command that permits users to manipulate data in database. It involves inserting data into database tables, retrieving existing data, deleting data from existing table, and modifying existing data. And lastly, let's talk about data dictionary. A data dictionary is a file or a set of files that contains a database metadata, or what we mean as data about data. The data dictionary contains records about other objects in the database, such as data ownership, data relations to other objects, and other data. So what you see here on the screen is a sample data dictionary report for a human resources database that provides helpful information such as the size of data element, which programs and reports use it, and which group in the organization is the owner responsible for maintaining it. The report also shows some of other names that the organization uses for the piece of data. So how does a database management system solve the problems of the traditional file environment? A DBMS can reduce data redundancy and inconsistency by minimizing isolated files in which the same data are repeated. The DBMS may not enable the organization to eliminate data redundancy entirely, but it can help control redundancy. Even if the organization maintains some redundant data, using a DBMS eliminates data inconsistency because the DBMS can help the organization ensure that every occurrence of redundant data has the same values. Also, the DBMS uncouples programs and data, enabling data to stand on their own. Access and availability of information can be increased, and program development and maintenance costs can be reduced because users and programmers can perform ad hoc queries of data in the database. The DBMS enables the organization to centrally manage data, their use, and their security. In the next section, let me show you how a DBMS helped Procter & Gamble. Procter & Gamble had to manage massive amounts of product data for its more than 300 brands. Because these data were stored in 30 separate repositories, the company could not easily bring together information about the company's various products and their components, degrading operational efficiency. Management of this data improved once P&G created a common set of technical standards for all its products and organized its data in a single global database. Let me show you how a database helps P&G manage product information.
Procter & Gamble P&G is one of the largest consumer goods companies in the world. With more than $43 billion in annual sales, P&G sells more than 300 brands worldwide, including major brands such as Tide, Mr. Clean, Ivory Soap, Crest, Pringles, Pampers, Clairol, and Prel. P&G has 5 global business units in more than 80 countries, including research and development and contract manufacturing operations. This dispersed business deals with 100,000 suppliers. The fundamental product development process at P&G begins with the creation of a set of technical specifications for a product, raw material, packaging material, piece of artwork, or analytical and process standards. Each P&G product has its own set of technical standards and specifications. In fact, P&G has more than 600,000 specifications and a mountain of product data to manage. These massive quantities of technical standards data used to be stored in 30 separate data repositories, preventing information sharing among researchers. Difficulties integrating and accessing this information made material acquisition more inefficient and expensive. P&G made the management of product information easier by cataloging the technical standards for all of its products and organizing them in a single global database called the Corporate Standards System, or CSS. The system is based on eMatrix from Matrix One, a provider of product lifecycle management software. This database is now available to 8,200 P&G employees and will be made available to some suppliers and contract manufacturers. The database organizes any and every piece of information that goes into making a particular product. Once this information is in the database, data can be analyzed from many different perspectives to deliver information to serve specific functions. Data in this system had also helped P&G cut down on total adhesive use and develop new processes for applying adhesives more economically. The database also enables P&G researchers who need constant access to standards to work more efficiently and facilitates reuse of technical standards that have already been defined. A researcher in one facility may have already defined a technical standard for a hair coloring gel, while another researcher may be working on a similar product or a product that may interact with that brand of hair color. When P&G's research and development group is working on new products, it can use this information without repeating the study to show that there is no problem with using the hair color in a new product. Apart from designing new products, big data analytics is also used to create global customer-centric marketing campaigns. According to an article on Computer Weekly, P&G knows which customers from where are engaged with what marketing program, and more importantly, why they are engaged with it. P&G has information on transactions, so they know their loyal customers are customers that could become loyal. They have created a conceptual architectural framework that places the customers at the center and monitors every touch point of the customers from online to in-store or on television. As such, P&G was able to create a website called Pampers Village for their diaper brand Pampers that offers advice, money-saving coupons, and free samples tailored to each stage of a woman's pregnancy or the baby's age. For P&G, big data analytics and the visualization of the data is extremely important. According to CIO Filippo Passarini, P&G is 2 or 3 years, perhaps more, ahead of anyone else. When talking about business intelligence, they can easily detect important key indicators early on, create a new predictive model, or use data to market a new product. For P&G, real-time analytics is critical. Therefore, P&G has institutionalized data visualization as a primary tool of management, as mentioned by Thomas Davenport. P&G has created decision cockpits for over 50,000 employees. These visual displays of the most important information help them make better decisions. In addition, P&G created so-called business spheres at over 50 locations where decision makers can view real-time information on large displays. These spheres create a truly immersive environment that physically surrounds business leaders with models. By creating these dashboards and rooms that deliver real-time analytics to the decision makers, P&G has created a data-driven, information-centric culture that helps them to stay ahead of their competitors. For P&G, it is all about knowing what's happening in the future instead of what happened last month or last year. Using the real-time analytics and dashboards, P&G has created a forward-looking view based on one version of the truth globally. This view has helped P&G getting the right tools and technology for the right people in the right places and building a data-driven, information-centric culture. Instead of discussing the sources of data or the quality of the data, decision makers at P&G now know that the data, brought into an understandable business context, is correct and that they can take faster and better decisions to answer the rapidly changing environment.
Continuing developments in information technology and its business applications have resulted in the evolution of several major types of database. First, operational databases. These databases store detailed data needed to support the business processes and operations of the e-business enterprise. They are also called subject area databases, or SADB, transaction databases, and production databases. Examples are a customer database, a human resource database, inventory database, and other databases containing data generated by business operations. This includes databases of internet and electronic commerce activities such as clickstream data describing the online behavior of customers or visitors to a company's website. Distributed databases. Many organizations replicate and distribute copies or parts of databases to network servers at a variety of sites. These distributed databases can reside on network servers on the World Wide Web, on corporate intranets or extranets, or on other company networks. Distributed databases may be copies of operational or analytical databases, hypermedia or discussion databases, or any other type of database. Replication and distribution of database is done to improve database performance and security. Ensuring that all of the data in an organization's distributed databases are consistently and concurrently updated is a major challenge of distributed database management. External databases. Let's start with access to data warehouses and data mining. A data warehouse stores data that have been extracted from the various operational, external, and other databases of an organization. It is a central source of data that have been cleaned, transformed, and cataloged so that they can be used by managers and other business professionals for data mining, online analytical processing, and other forms of business analysis, market research, and decision support. Next, what do we mean by data mining? Data mining is a major use of data warehouse databases. In data mining, the data in a data warehouse are analyzed to reveal hidden patterns and trends in historical business activity. These can be used to help managers make decisions about strategic changes in business operations to gain competitive advantages in the marketplace. Implementing data resource management managers and business professionals need to view data as an important resource that they must manage properly to ensure the success and survival of their organizations. But this is easier said than done. Let's talk about database administration. Database administration is an important data resource management function responsible for the proper use of database management technology. Database administration includes responsibility for developing and maintaining the organization's data dictionary, deciding and monitoring the performance of databases, and enforcing standards for database use and security. Data planning is a corporate planning and analysis function that focuses on data resource management. It includes the responsibility for developing an overall data architecture for the firm's data resources that ties with the firm's strategic mission and plans, and the objectives and processes of its business units. Data planning is done by organizations that have made a formal commitment to long-range planning for the strategic use and management of their data resources. And lastly, data administration. Data administration is another vital data resource management function. It involves administering the collection, storage, and dissemination of all types of data in such a way that data becomes standardized resource available to all end users in the organization. The focus of data administration is the support of the organization's business processes and strategic business objectives. At this point, let's talk about the challenges of data resource management. The data resource management approach provides business managers and professionals with several important benefits. Database management reduces the duplication of data and integrates data so that they can be accessed by multiple programs and users. Software is not dependent on the format of the data and the type of secondary storage hardware being used. Business professionals can use inquiry response and reporting capabilities to easily obtain information they need from databases, data warehouses, or data marts without complex programming. Software development is simplified because programs are not dependent on either the logical format of the data or their physical storage location. Finally, the integrity and security of data is increased since access to data and modification of data are controlled by data management software, data dictionaries, and a data administration function. The challenge of data resource management arises from its technological complexity and the vast amounts of business data that need to be managed. Developing large databases of complex data types and installing data warehouses can be difficult and expensive. More hardware capability is required since storage requirements for the organization's overhead control data and database management or data warehouse software are greater. Longer processing times may also result from this additional data and software complexity. Finally, if an organization relies on centralized databases, its vulnerability to errors, fraud, and failures is increased. Yet, problems of inconsistency of data can arise if a distributed database approach is used. Therefore, supporting the security and integrity of their databases and data warehouse management is a major objective of data resource management for e-business enterprises. Just imagine how difficult it would be to get any information from an information system if data were stored in an organized way or if there was no systematic way to retrieve it. Therefore, in all information systems, data resources must be organized and structured in some logical manner so that they can be accessed easily, processed efficiently, retrieved quickly, and managed effectively. Thus, data structures and access methods ranging from simple to complex have been devised to access data stored by information systems. Here, we will explore these concepts as well as the more technical concepts of database management. Now let's start with hierarchical structure. Early mainframe DBMS packages used a hierarchical structure in which the relationships between records form a hierarchy or tree-like structure. In the traditional hierarchical model, all records are dependent and are arranged in multi-level structures consisting of one root record and any number of subordinate levels. Thus, all of the relationships among records are one to many since each data element is related to only one element above it. The data element or record at the highest level of a hierarchy, the department data element in this illustration, is called the root element. Any data element can be accessed by moving progressively downward from a root and along the branches of the tree until the desired record, for example, the employee data element, is located. Next is the network structure. The network structure can represent more complex logical relationships and is still used by some mainframe DBMS packages. It allows many-to-many relationships among records. That is, the network model can access a data element by following one of several paths because any data element or record can be related to any number of other data elements. For example, departmental records can be related to more than one employee record, and an employee record can be related to more than one project record. Thus, one could locate all employee records for a particular department, or all project records related to a particular employee. The next is relational structure. The relational model has become the most popular of free database structures. It is used by most microcomputer DBMS packages as well as by many mid-range and mainframe systems. In the relational model, all data elements within the database are viewed as being stored in form of simple tables. Relational database model may include two tables representing some of the relationships among departmental and employee records. Other tables or relations for this organization's database might represent the data element relationships among projects, divisions, product lines, and so on. Next is multidimensional structure. The multidimensional database structure is a variation of the relational model that uses multidimensional structures to organize data and express the relationships between data. You can visualize multidimensional structures as cubes of data and cubes within cubes of data. Each side of the cube is considered a dimension of the data. Each dimension can represent a different category, such as product type, region, sales, channel, and time. Each cell within a multidimensional structure contains aggregated data related to elements along each of its dimensions. For example, a single cell may contain the total sales for a product in a region for a specific sales channel in a single month. A major benefit of multidimensional databases is that they are a compact and easy to understand way to visualize and manipulate data elements that have many interrelationships. So, multidimensional databases have become the most popular database structure for the analytical databases that support online analytical processing, or OLAP, in which fast answers to complex business queries are expected. And the last one, object-oriented structure. The object-oriented database model is considered to be one of the key technologies of a new generation of multimedia web-based applications. An object consists of data values describing the attributes of an entity, plus the operations that can be performed upon the data. This encapsulation capability allows the object-oriented model to better handle more complex types of data, like graphics, pictures, voice, text, etc., than other database structures. The object-oriented model also supports inheritance. That is, new objects can be automatically created by replicating some or all of the characteristics of one or more parent objects. Information is the oil of the 21st century, and analytics is its combustion engine. In today's world, every organization relies on data to make accurate decisions and strategies. Relevant, accurate, and actionable data largely contributes to the growth of an organization. If not managed meticulously, it can prove to be useless and even detrimental to a scaling enterprise. Therefore, proper data management initiatives should be implemented to ensure the authenticity of data, increase its quality, and maintain accuracy. So if you have not implemented a data management system into your organization yet, then this is the right time to get one. Let us start turning our data into information and information into insights. Once again, this is Rubero C. Baldovino from Management Information System. Thank you so much for watching.